Hello everyone, welcome to another video on machine learning. Up to this point, we have seen several regression and classification algorithm. So we are going to take a break from this. Right, regression and classification, both of them were kind of supervised learning. All right, where we were given features and target. We trained on these features and the target that we were given, and then we made some sort of a prediction. In regression, we gave a real number at us as our output, and in classification, we had to give a discrete value as our output. Right, so that was the kind of thing that we did up to this point. Right, so these were supervised learning. Then in this video and in the next few videos we are going to take a break from supervised learning, and then later on we are going to go back and talk about more about supervised learning. All right, specially we are going to talk more about classification. We are going to look at more methods to do classification later on. All right, so in this video we are going to look at something called unsupervised learning. Now in unsupervised learning there are different tasks that we may have to do. All right, for example, there are three things in unsupervised learning that we are going to look at in this course. So in today's video, we are going to look at something called clustering. In the next video, we are going to look at something called association rule mining. And later on, we are going to look at something called dimensionality reduction. All right. So clustering, we will see very soon what is clustering. But let me tell you a bit about what is coming in the next video. In the next video, we are going to look at something called association rule mining. Association rule mining essentially is when you go to a website like Amazon.com, okay, and you buy something. Say you go to a product page, all right, you see this people who bought this also bought this, right? So those kind of algorithm that figures out from data what to suggest, right? Or if you go to next Netflix, if you watch Harry Potter and what Philosopher's Stone and then Harry Potter and the Chamber of Secrets, so the Netflix algorithm is going to suggest Harry Potter and the Prisoner of Azkaban. Say you have seen movie 1 and movie 2, so those algorithm is going to suggest movie 3 to you. All right, so this kind of rules that people, if they buy bread and they buy milk, go ahead and suggest sugar to that person. So generating this kind of rules from the past history. All right. So this kind of things is association rule mining. We are going to look at algorithms to do this kind of things in the next video. In today's video, we are going to look at something called clustering. So let us go ahead and talk about what is clustering. Alright, so clustering is the content of today's video. Clustering is the task of dividing the population or data points into a number of groups such that data points in the same group are more similar to other data points in the same group than those in other groups. In simple word, the aim is to segregate groups with similar trait and assign them into clusters. Alright, lots of words in this text. So basically the idea is simple, right? So say we have data of lots of people who goes to big bazaar, okay, and then what we want to do is we want to group all these customers who goes to big bazaar based on their buying pattern. So a person who buys lots of cosmetics, all right, all the people who buys lots of cosmetic should be in one group. All the people who buy groceries should be in another group. All the people who buys clothes should be in yet another group. All right, and then what we may have people who buy cosmetic and clothes. These two groups that we have, okay, these two can come together and make a bigger group, right? So we these kind of things where we segregate, right, segregate groups with similar traits. So all the people who buy clothes, they share some similarity, right? So they are different from this group of people who buys groceries. So all the people who buy grocery would be one cluster. All right. So one group. Those groups are called clusters. All right. So this process is called clustering. Alright, very simple. Now let us talk about clustering. Let me give you another example. Remember the iris dataset. In iris dataset, we had four features: sepal length, petal length, sepal width, and petal width. And then we had this target. What is the species of this particular flower with this particular features. All right, so that was the data set that was given to us. Now we did lots of we applied lots of classification algorithms on this kind of data set. We did that. All right, but in clustering, what would happen is we would be given the features. All right, sepal and petal length, sepal width and petal width, but we will not be given the target. All right, we will not be given what is the species of this flower. But then what we will have to do is we will have to take this data set, take this iris data set's features, and then group all these rows. All these rows are different flowers, right? So we have to group all these different rows into three different groups. All right, one would be the group, one would contain all the rows that has that are of iris setosa. Another group will contain all the rows that belongs to iris versicolor, and the third group would contain all the rows that has iris virginica. All right, so we will not be given what is the flower. We will be given what are the features, sepal and petal width, sepal width and petal width, and then we have to do these groupings. All right, so that is another example of clustering. Right, so let us go ahead and talk about this. There are two different ways of doing clustering. One is hard clustering and one is soft clustering. All right, in hard clustering, each data point belongs to only one group. All right, so it either belongs to one cluster or it does not belong to the cluster. All right, so compare that to soft clustering. In soft clustering, what is going to happen is uh, our data points will have probability. All right, so probability of it belonging to, say, my flower, probability of it belonging to this group of iris setosa or belonging to group of versinica or uh, versicolor. All right, so there will be probability given. What is the probability that I belong to cluster A or cluster B or cluster C? Compare that to hard clustering. In hard clustering, I will simply say it belongs to cytosa or not. Okay, it either belongs or it does not belong. There is a 1-0 kind of thing. In soft clustering, there is a number between 1 and 0, all right, some real number that indicates what is the probability of it belonging to that group. It's a simple concept, right? So yeah, those are two different types of clustering that we can do. Most of the algorithms, in fact all the algorithms in this video and all the algorithms that we are going to study related to clustering in this course are of hard clustering type. All right, so we are keeping things simple in this course because this is an introductory machine learning course, right? Not an advanced one. All right, in this video, we are going to look at three different algorithms: k-means, hierarchical clustering, and we are going to look a bit about DBSCAN. So everything is capital here. Uh, just we are going to have a very brief overview of DBSCAN. All right. So these three algorithms are the one that we are going to study in this video. So DBSCAN is DB scan. All right, everything is capital. I wrote scan in small, so that was an error. Okay. Now, before we go ahead and look at any of the algorithm, we will need this concept of distance. All right. So we will be talking about distance a lot in this video. So all this distance that I'm going to find will be using Euclidean distance. All right. So we will be finding Euclidean distance. Whenever you hear me saying the word distance, understand that we are talking about Euclidean distance. So if you recall from the video on k nearest neighbor, in the video on k nearest neighbor we saw several different distance metrics. All right, you can go ahead and use any of them in this course. It is not necessary that you have to use Euclidean distance, but we are going to do that, right? We are going to use Euclidean distance. So if you remember Euclidean distance between this point, say I have this point P and this point Q. So the distance between P and Q is root over 6.1 minus 5.1 square plus 3.5 minus 3. or 3.0 minus 3.5 square, it does not matter which one you write before, which one you write after. We are going to square it, so the negative will get positive. I hope you understand what I am saying. This is school mathematics. 4.6 minus 1.4 square plus 1.4 minus 1.0 square. Alright, so this is the formula. The number is going to be 3.59. So the distance between P and Q according to Euclidean formula is this. Alright, so yeah, I'm not going to talk more about Euclidean distance. If you have any doubts, go back and watch the video on K nearest neighbor. Alright, so in that video we talked about distances in details. Alright, the first algorithm that we are going to talk about is the k-means algorithm. K-means clustering is the method of vector quantization originating from signal processing that aims to partition. So here what we are going to do is we are going to partition n data points. Alright, we have n data points and we are going to partition them into k clusters. Alright, each observation belongs to the cluster with the nearest mean. Right, serving as a prototype of the cluster. So each cluster is going to have some thing called mean. Right, you know what is a mean in statistics, so you know what is mean, median, mode. So we are going to look at what is the mean of a cluster, and we are going to use that to determine a data point is going to belong to which cluster. All right, so we are going to talk about all of these things with examples. All right, so let us go ahead. This is the definition. The takeaway from this definition is this: k-means, in k-means, what do we do? It is a vector quantization method. That means it's essentially clustering method. Okay, where what we try to do is we try to take this n data points and we divide them into k different cluster. All right, and based on what? Based on what is the nearest mean. So you will see what is mean very soon as we work on some example, and this mean is what defines the cluster. So this mean serves as the prototype of the cluster. All right, so yeah, that is what it is. Don't worry too much about the definition, just understand how the algorithm works. That is more important. Okay, now in k-means, what do we have? We have k different means. Okay, mean value. Now there are two steps in this algorithm. First, the assignment steps. In assignment steps, what happens is this: we assign is an observation to the cluster with the nearest mean. All right, so we have created three different means. All right, we are doing k means with k equal to 3 over here. Okay, so we are trying to do k means with k equal to 3. We have randomly initialized three different mean. All right, then what do we do? From this mean, say I am trying to find distance of all the points that are there in my data set. Alright, so I will find the distance of all the points in my data set. First from the red mean, then I will do the same thing from blue. I will find the distance to all the points from the blue mean and from the green. Alright, now this point, I see that this is nearest to my red mean. Alright, so this would belong to the class defined by the red. This point, it is nearest to the red mean, so this would belong to the red's class. This point, okay, the nearest mean, is it blue, is it green, or is it red? The nearest mean to this point is green, so this will belong to the green class. In this way, what we have done, these three means that we have randomly initialized will divide the entire area. Okay, all the points in this area is nearest to this red mean. Alright, this will belong to the red class. Then this is nearest to green, sorry. All the points in this area is nearest to the green mean. Alright, and all the points in this area is nearest to the blue mean. Alright, so this is how the area is divided. Okay, everything in this area will be nearest to this. everything in this area will be nearest to this, and everything in this area will be nearest to this. So this kind of a diagram is called a Fornoid diagram. I'm not going to go into that. Right? That is not necessary from our perspective in this video. Okay, so in this way what we do is we divide uh, our entire data set. Okay, we assign every point in our data set to one mean. So this mean is assigned all this and this points. So all these points are nearest to this mean. All these points are nearest to this means, and this point is nearest to this mean. Alright, so this is what we have done. Uh, in this way, each row in our data set is assigned to one of the means. Now, this is the assignment step. Okay, we are done with assignment step. Next, we have to do the update step. In update step, what we do, we recalculate mean. So all this mean, we recalculate them. Alright, how do we recalculate? Say this and this were the points that belong to this class, right? This cluster. So all these were points that belong to the green mean. Okay, the cluster defined by the green mean. So now in our update step, we are going to update the mean. How are we going to update the mean? Our new mean is going to be the average of all the points that are there in this cluster. Alright, the green mean defined a cluster. Alright, what are the data points that were there in the cluster? All the data points that are nearest to green. So each point we are going to figure out what the distance from all the different means that we have. Alright, so we can have k different means. Here k is equal to 3, so we have 3 different mean. So each data point we are going to see what is the nearest mean. Okay, I am using this word mean. I can also use this word centroid. Okay, so let me go ahead and use the word centroid. So I am going to figure out which is the nearest centroid. All right, for each of the point. Now once I have figured out which is the nearest centroid, then I am going to group all these points, right? So these points nearest centroid was this, so this belong to one group. All these points nearest centroid was this, so these belong to another group. All these points belong to another group. This was one cluster. Similarly, all these points nearest centroid was this, so all these points belong to another cluster. In this way, we have created cluster. Alright, this was our assignment step. Next, in our update step, what are we going to do? Our mean, our centroid, we are going to update them. How are we going to update them? These were all the points in our cluster, right? Say, how do I update the green centroid, the green mean? All these points were in the green cluster, right? So I am going to take the average of all these points, and that is how I am going to update my mean. This green centroid was over here. Now after the update it has come here, right? So this is how I do the update. Then what do I do? Then I do this entire process again. My mean was here. All right, my mean red mean was here. From that it was updated to this point. My green mean was here. From that it was updated to this point. My blue mean was here. From that it is updated to this point. All right, so in this way I have done this update, and then I run this again. Each of the data point I figure out what is the nearest mean. So this is my updated mean. I figure out what is the nearest mean of this data point. So I see this is red. Okay, this also belongs nearest centroid. Nearest mean is red. For this and this, the nearest centroid is this. All right. For this and this, the nearest is this. All right. So in this way, we keep repeating. Up to what point do I repeat? The algorithm has converged when the assignment no longer changes. So I repeat up to the point when there is no longer any change. Okay. So up to that point we are going to repeat this process. Alright. So when is there not going to be any change? See here, after this assignment, okay. After this update, see, previously I had this point belonging to green class or a green cluster. Then after this update and running this entire process again, this point now belongs to the red cluster. Alright, so there was some change. Now if I keep on repeating this, I will come to a point where uh, this all the classes stay stagnant. Okay, there is not going to be any more change. So when that happens, we are going to end our algorithm. Right. And now there is one more thing. The algorithm is kind of greedy. Okay, so we are going to find local optima. Uh, Finding the perfect base cluster is NP hard. So it will take a exponential amount of time. This algorithm that we just talked about, it is just a heuristic. All right, so let us if you have any confusion, let us go ahead and work with a real data set instead of all these diagrams, and I hope by the end of that you will the confusion that you have will go away. Okay, so this is the data set that we are going to work with. So we have data for 7 people, the amount of time they spend on Facebook and the amount of time they spend on Instagram. So we are going to find two clusters. One of them is going to be casual social media user, and the other is going to be mobile addicts. Okay, so high user. So essentially we are going to find two groups. So we are trying to find two clusters. All right, therefore our k is going to be equal to 2. Okay, now the first thing that I'm going to do is I'm going to randomly create two means. All right, now how do I randomly create two means? You can create random points in your space. That is something you can do. But what I'm going to do is I'm going to choose two random rows from my data set. So let me go ahead and randomly choose 1 and 4. These are the 2 points that say I have randomly chosen. Alright, now let us go ahead and start doing k-means. Alright, so what is our target? Our target is to divide this data set into two clusters, two groups of user. Alright, so why am I saying 2? My k is equal to 2. Alright, so because I try to divide this data set into two groups, two clusters, I have set k equal to 2. Alright, and yeah, let's proceed. What we have done, we have created two centroid up to this point. So we have randomly initialized two mean, this point and this point we have randomly initialized as mean. Now I'm going to find distance from the mean to each of the point. Okay, so this is my cluster 1's centroid, this is my cluster 2's centroid. All right, now let me go ahead and find the distance of this point from this centroid 1. So distance of this is going to be 1 1 and this is 1 1. So 1 minus 1 square plus 1 minus 1 square, and this is going to be 0. What is the distance from centroid 2? This is going to be 1 minus 5 square plus 1 minus 7 square, and this is equal to 7.21. Okay, so I have figured out the distance from cluster 1 and cluster 2. Okay, the distance is 0 and 7.21. Now for the second point, let us go ahead and figure that out. For the second point, distance from cluster 1 is going to be, this is the mean of cluster 1, the centroid, the mean of cluster 1, and this is my point. Okay, so the distance, Euclidean distance, is going to be 1.5 minus 1 square plus 2 minus 1 square, and that is equal to 1.12. And then I have to find from the second cluster, the second cluster's centroid. So let me go ahead and find that. this is 1.5 minus 5 square plus 2 minus 7 square. Alright, and this is equal to 6.1. So this is 1.12 and this is 6.1. Okay, now in this way I can find all this number. Let me do one more row. This is going to be this is, what am I trying to find here? I am trying to find the distance from cluster 1, the mean, the centroid of cluster 1. Alright, the distance of this point is 3.5, 4.5. So the distance of this point from the centroid of cluster 1. What is the centroid of cluster 1? This thing. Alright, 1, 1. So let me go ahead and find that. This is going to be 3.5 minus 1 square plus 4.5 minus 1 square, and that is equal to 4.3. So this distance is equal to 4.3. And what about this? What am I trying to find here? I am trying to find the distance of this point. What is the point? 3.5, 4.5. From where am I trying to find the distance? I am trying to find the distance of this point from the centroid of cluster 2. Okay, we are going to find two clusters. We are going to have two centroid of two clusters. Why 2? Because we had said k equal to 2. Why did we set k equal to 2? Because we are trying to find two different clusters, two different groups. The casual user of social media, heavy users of social media. Right. So yeah, let us go ahead and find that. The Euclidean distance is 3.5 minus 5 square plus 4.5 minus 7 square, and this is equal to 2.92. So the value here is going to be 2.92. Alright, so I hope this makes sense up to this point. What did we do up to this point? We initialized two random mean at the very beginning. At the beginning we don't know what to initialize as our centroid, right? So we randomly initialized two centroid. How did we do that? We selected 2 points from our data set, okay, and we made them centroid. So we had selected this point and this point as our random points. So these were the two random centroids that we had selected. To what is the role of this centroid? This centroid defines two different clusters. Okay, these are the center thing of these two different clusters. All right, so we had initialized two different centroid randomly from our data set, and then for each of the point we found out the distance from both of these centroid. All right, so for cluster 1's centroid we found the distance between this point and this point. This is equal to 0 because this point itself is the centroid, so the distance from me to myself is 0. Then we also found from the other centroid. All right, in this way we have filled out this table. This is the filled table. All right, so once we have filled out this table, now we are going to do iteration 1 clustering. All right, so what we are going to do, does person 1 belong to cluster 1 or cluster 2? So we had two different clusters. This was one cluster and this was another cluster. Alright, this cluster's centroid or mean was this. This cluster's centroid or mean was this. Alright, so we had two different clusters. Now I have to figure out each of these points, do they belong to cluster 1 or cluster 2? Alright, this point, the distance from cluster 1 is 0, the distance from cluster 2 is 7.21. So it makes sense that this would belong to cluster 1. This point, the second point, distance from cluster 1 is 1.12, distance from cluster 2 is 6.1. So this would also belong to cluster 1. Here, third point, distance from cluster 1 is 3.61. Distance from cluster 2 is also 3.61. So what to do here? We have to make a choice. Okay, let me go ahead and assign it to cluster 1. Not a problem. It can be anything. Okay, we could have very well assigned it to cluster 2. but I am assigning to cluster 1. It depends on how you wrote the program. Okay, really. Now, row number 4, distance from cluster 1 is 7.81, distance from cluster 2 is 0. Why is it 0? Because 4 was the centroid that we randomly chose to describe cluster 2, right? So, yeah. So, the distance from this point to this point would be 0. Alright. So what is the nearest centroid? Is it clusters 1 centroid or clusters 2 centroid? So distance from clusters 2 centroid is 0. That is the nearer of these two. So this row, this data point, row number 4 would belong to cluster 2. Okay, because centroid of cluster 2 was nearer to this point. Similarly, in row number 5, distance from cluster 1's centroid is 4.72, distance from cluster 2's centroid is 2.5. So cluster 2's centroid is nearer to this point. So this point will also belong to cluster 2. Alright. Similarly, the other 2 points here also cluster 2 is nearer. Cluster 1's centroid is 5.32, cluster 2 centroid is 2.1. This will also belong to cluster 2. In the final row, clusters 1 centroid is 4.3 distance away. Cluster 2 centroid is 2.92 distance away. So this final row would also belong to cluster 2. Alright, so we are done. Iteration 1 is done. We have done the first step of our classification. Okay, fine. We have assigned the cluster. This 3 belongs to one cluster, this 4 belongs to another cluster. Okay, now our assignment step is done. We have assigned a cluster to each of the points, or we have assigned points to each of the data points to each of the cluster. Alright, to our cluster 1 we have assigned these 3 data points, to our cluster 2 we have assigned these 4 data points. Okay, our assignment step is done. Now we have to do the other step. We have to do the update step. So what are we going to do in the update step? We are going to update the centroid. How are we going to update the centroid? We are going to find the mean. Alright. So new clusters 1 centroid is going to be these 4 points belongs to cluster 1, right? So it is going to be 1 plus 1.5 plus 3 divided by 3. This is how I find the mean of hours on Facebook. And then 1, 2, 4, 1 plus 2 plus 4 divided by 3. This is the mean of hours on Instagram. And this is equal to 1.83, 2.33. Alright. So this is how I have updated the centroid. Alright. In my update step, previously I had taken a random centroid. Now I am updating the centroid. How am I updating the centroid? I am taking the mean. Okay. There are two features, hours on Facebook and hours on Instagram. So this mean would also have two features. How am I taking finding the first feature? Feature indicating hours on Facebook. All these rows that belongs to this cluster 1. Alright, I am taking the mean of that feature. So I had 1, 1.5 and 3. I am taking the mean of them. So I am doing 1 plus 1.5 plus 3 divided by 3. There were 3 rows in my data set, therefore divide by 3. I do similar thing for hours on Instagram. I had 1, 2 and 4 in my hours of Instagram for these 3 points that were there in my cluster. So I take the sum of all this feature, all this 1, 2 and 4, and I divide by 3. That is how I get this 2.33. So this is my new updated mean, my new updated centroid. Alright, for cluster C1. Now I have to find for cluster C2 as well. So new, this cluster C2 centroid is equal to 5. The so there are two axes on my uh, data, right? There is this one axis indicating hours on Facebook, the other axis indicates hours on Instagram. So let us first find the mean for the hours on Facebook axis. So I have in my feature hours on Facebook, I have 5, 3.5, 4.5 and 3.5. Okay, so I will sum all these values. Let me do that. 5 plus 3.5 plus 4.5 plus 3.5. So this is the sum, and I divide by 4 because I have 4 different data points over here, and that would give me the mean of this axis, and I have to find the mean of this axis as well. So this is going to be 7 plus 5 plus 5 plus 4.5 divided by 4, and this is going to be 4.12, 5.37. All right, so this is my new my cluster one's new centroid, new mean. All right, we randomly initialize this and this. Now we have this and this as our updated centroid. All right, so we are done updating our centroid. Fine. Okay, so these are the updated centroid that we found. Now we have to find the distance again. We have to repeat this step. We have to find the distance of each of the point from this updated uh, using this updated centroid of these two clusters. So let me find the distance of row number 1 from cluster 1. So cluster 1's centroid is this. So how do I find the row? I have 1 1. So 1 minus 1.83 square plus 1 minus 2.33 square, and this is equal to 1.5 almost. All right, so this is the distance from what? This is centroid 1's mean, and the distance of this point from centroid 1's mean, right? So this is this distance from new centroid 1, cluster 1. All right, now let us go ahead and find the distance from cluster 2's mean. So this is the mean of cluster 2, and I'm going to find from this point 1 1. So 1 minus 4.12 square plus 1 minus 5.37 square, and this is equal to 5.4. So this is 5.4. Okay, now let me do one more point. Let me find the distance of this seventh row from cluster 1. So cluster 1's centroid is this. Okay, the distance is 3.5 minus 4.12 square plus 4.5 minus 5.37 square equal to, this is equal to 2.8. All right, and then let me find the distance of this 7 point itself from the centroid of cluster 2. All right, so this is equal to 3.5 minus 4.12, sorry, okay, I made a mistake. Okay, this was not the mean from clusters 1's centroid. Okay, this was the mean from cluster 2's centroid. Okay, and this is equal to 1.1. Okay, let me find the distance from cluster 1's centroid now. So this is cluster 1's centroid. This is 3.5 minus 1.82 square plus 3.5 minus 2.33 square, and that is equal to 2.8. So this is 2.8, this is equal to 1.1. Okay, so I hope you got this, how we figured this out. Okay, This is the distance of 3.5, 4.5, this point 3.5, 4.5 from this point. 4.1 to 5.37. The distance of this 2 point is the distance of cluster 2 and the point. Okay, so why is the distance of this why is it the distance from cluster 2 and that point? Because this is the centroid that defines cluster 2. Alright, this is the centroid that defines cluster 2, and this is the point that we are trying to find the distance from. Alright, so we find the Euclidean distance between these 2 points, and that is how we find this, the distance from cluster 2. And in the same way, this is the centroid. This is the centroid that defines cluster 1, and then this is the formula to figure out the distance of the point 3.5, 4.5 from cluster 1. Alright, this is the centroid of cluster 1, and that is how we figure out the distance. Alright, so this is what we do essentially, not a very, hopefully not a very difficult thing to understand. Alright, so we have two different clusters. These two clusters are defined by two different centroid. So for each of the point we find the distance from both of the centroid. Alright, so that is what we do, and this is how we figure out the distance of each of the point from both of the centroids. Alright, now what we have here is this gives us the previous cluster in our last iteration that we have. Now let us find out the cluster after this iteration. Alright, this is the distance from centroid 1, this is the distance from centroid 2. So which one is nearer? Centroid of cluster 1 and centroid of cluster 2. Alright, so which one is nearer? Centroid of cluster 1 is at a distance of 1.5. Centroid of cluster 2 is at a distance of 5.4. So it seems centroid 1 or centroid of cluster 1 is nearer. So I am going to assign this point to cluster 1. Next, second row, distance of the second point from cluster 1's centroid is 0.4. Distance of second point from centroid of cluster 2 is 4.3. So cluster 1 once again is nearer. So I'm going to assign this to cluster 1. Here distance of cluster 1 is 2.1, distance of cluster 2 is 1.8. So distance of cluster 2 is nearer, going to assign this to cluster 2. All these rows, distance of cluster 2 is smaller than distance from cluster 1. Alright, so cluster 1's centroid is at a further distance than cluster 2's centroid. So going to assign this row to cluster 2. For the same reason, this will be cluster 2, and cluster 2. Alright, now one thing that we should notice is that we have a change over here. Alright, so we cannot stop our algorithm right now. Alright, why cannot we stop? Because there is some change. We have to stop when there is no longer any change. Okay, so let us go ahead and do one thing. We are going to now have this as our cluster 1, and we have this as our cluster 2. Alright, so we have to find new centroid of cluster 1. Okay, how are we going to find that? We take the average, right? So we take this average, 1 plus 1.5 by 2 and 1 plus 2 by 2, and this is going to give us 1.25 and 1.5. Alright, this is the new centroid, this is the new mean of cluster 1. Similarly, we have to find new mean or centroid of cluster 2. This is going to be, we add up all these values, right? 3 plus 5 plus 3.5 plus 4.5 plus 3.5 divided by how many points do I have? I have 1, 2, 3, 4, 5 points. Right. In the same way we do this with this feature as well. 4 plus 7 plus 5 plus 5 plus 4 divided by 5, and this is going to be 3.9, 5.1. Alright, so this is the uh, second the centroid of the second cluster. Alright, so this is how we have assigned clusters again. Okay, in our second iteration we first assigned new clusters and then we updated the mean. Okay, we are done. Now let us go ahead and work with our third iteration. We are done with second iteration. Okay, now we are ready to do third iteration. So what we have to do is this, we have to figure out the distance. uh, these are our updated centroid. So each of these two clusters C1 and C2, we have two clusters. Okay, and we are going to find the distance of each point from this two centroid defining these two clusters. All right, so distance of point 1 is going to be 0.56, distance of point 2 is going to be 5.02. All right, in the same way we will figure for each of them out. Let us go ahead and fill this up. Yeah, these are the points that I have. Now let us go ahead and assign this clusters to each of the point. Okay, so here row number 1, distance from cluster 1 is less than distance from cluster 2, so going to assign this to cluster 1. Row number 2, same thing, going to assign this to cluster 1. Row number 3, cluster 2 has lower distance, so going to assign this to cluster 2. Row number 4, cluster 2 has lower distance. Row number 5, cluster 2 has lower distance. Row number 6, cluster 2 has lower distance. And finally row number 7, once again cluster 2 has lower distance. Okay, now we are done assigning new clusters. Okay, is there any difference? This was the clustering that we did in our last iteration. This is the clustering that we are doing right now. So this row there is no change, this row there is no change, no change, no change, none, none, no change here as well. Okay, so there is no change in any of the row. Okay, so we are done. We are done with our clustering. We have divided all these points into two different clusters. Point number 1 and 2 belongs to one cluster. We are calling this C1. Point number 3 to 7 belongs to another cluster. We are calling this C2. Okay, so this is essentially k-means, a very simple algorithm once you understand what is happening. And this, I hope you have understood what is happening. All right, nothing very complicated, uh, just ideas that we have already explored in KNN. We are applying in k-means to do a entirely different task. We are doing clustering over here. We did classification with KNN, and we talked a little bit about how to modify that classification algorithm to do regression in KNN, but let's not talk about that. Uh, so yeah, this is what it is. So this is how we have done clustering. So all these 7 different people we have divided into two groups. These two people belong to one group, and these 5 people belong to another group. So this would be the group of people who are casual social media users, and these are group of people, this 5 belongs to heavy social media user. Now if you look at the data, this would make sense, right? This person uses Facebook 3 hours every day, this person uses Instagram 4 hours every day, right? So this person uses social media 7 hours per day, compared to person number 1, he is using social media 2 hours per day, 1 hour on Facebook, 1 hour on Instagram, right? So yeah, all these people are heavy users, all these people are light users. So we have divided all these points into two different groups, two different clusters. How did we do that? We did that using KNN. What is the process to do KNN? At the very beginning we assign random centroid. All right, and then using this random centroid, how many random centroid? K number of random centroid. In our example, k was equal to 2 because we wanted two groups. All right, so we have k different random centroid. How did we find that random centroid? You can randomly initialize them, or in our case what did we do? We selected randomly two different points, this k different points from our data set. All right, now this random centroid, all right, are going to define these k different clusters, these k different random centroid are going to define k different clusters. Next, what do we do? For each row in our data set, we figure out which of these k different random centroid is nearest to me. Okay, nearest to each of the point. The centroid that is nearest to one point, this point is assigned to the cluster defined by that centroid. Alright, so that is what we did in the assignment step. Then what did we do? After this assignment step was done, then we did the update step. In our update step, what did we do? We took the average of all the points that were there in the cluster, and that is how we updated the centroid. Alright, we took the mean of all the points, and that is how we got the updated centroid. Okay, that was, we updated the centroid in our update step. Alright, once we have done our update step, what is the next thing to do? We do this assignment again. This, using this new updated centroid, we figure out what is the distance from each of the point. Okay, so for each of the point, what is the distance from each of the centroid? Okay, which is the nearest centroid for each of the point? So for each of the point, the centroid that is nearest to them, okay, we assign each of the data points to the cluster that is defined by the centroid that is nearest to them. Okay, so we do this assignment again, and then after doing this assignment again, we update the centroid again. Okay, we keep on doing this. How long do we do this? We do this until and unless there is no more change in assignment. Okay, once we have no more change in our assignment, at that point we stop. Okay, and then at the end of that, we would have defined different clusters using our data. We would have divided our data into different groups, into different clusters. Alright, so this is k-means, a very simple algorithm if you think about it. Okay, now there is one question that of course people are going to ask: how good is our clustering? Okay, is our clustering good? So for that we are going to find something called sum of square deviation. Yeah, how do we find that? So this points cluster's centroid was this. Okay, so I am going to find the distance of this point. Okay, let me not write the Euclidean formula. Let me write this: distance of point 1 and centroid of point 1. What is centroid of point 1? Centroid of point 1 is the centroid of the cluster to which point 1 belongs. Point 1 belongs to this cluster, C1 cluster, and what is the centroid of C1 cluster? This point, right? So distance of this from this is one distance. So we are going to take the square of this distance plus distance of person 2 from centroid of the cluster of person 2, okay, square, plus distance of person 3 centroid of the cluster of person 3 square. We do this for all data points: distance of person n centroid of cluster of person n. Okay, so what is the centroid of this person of person 3? So this is person 3, he belongs to cluster C2. The centroid of cluster C2 is this point. So this is the centroid of P3, sorry, C2 means cluster 2, and person 3 belongs to cluster 2. So this is the centroid that defines uh, P3. Okay, so yeah, this is what we do. This is how we find the distance of each of the point from its centroid. Okay, from its cluster centroid, we take the square and then we sum them up. So that is sum of squared deviation, sum of squared distance. Okay, so this is one metric that we have. Okay, sum of square deviation. I hope this is not a very difficult idea to grasp. Okay, let me just show for two rows. Okay, I will do for this row and this row. Okay, the distance of this row, how am I going to find that? From its centroid, what is the centroid of this row? This row belongs to cluster 1. The centroid of cluster 1 is this point. Okay, so I have to find the distance of this, and that is equal to 1.5 minus 1.25 square plus 2 minus 1.5 square, and this is equal to 0.56. And then what is the distance of this point from its centroid? This point belongs to cluster 2. The centroid of this point is this. Alright, so this is going to be 3.5 minus 3.9 square plus 5 minus 5.1 square, and that is equal to 0.41. Alright, yeah. So this is 0.56, this is also 0.56. This is I will find the distance of this point from this point belongs to cluster 2. This is the centroid of cluster 2, so this distance is going to be 1.42. This distance is going to be 2.19. This distance is 0.41, just figured out. This distance is also 0.41. Oh no, sorry, this is 0.61. Right, and this distance is equal to 0.72. Okay, so these are all the distances. We have to take sum of squared distance. Right, so we square all these values, all these distances that we found, and then what do? We sum them. So we sum all of this, and that is how we get the sum of square distance. So we take the sum of square of the distance. Alright, so this is the metric that we use to do clustering. Now what is the use of the metric? Now one question that we did not ask till now, what should be a good value of k? Okay, so let us ask that question and answer that. What is a good value of k? Now we will take k equal to 1, k equal to 2, k equal to 3, 4, 5, 6. We will try all this thing out. Okay, so once we have uh, tried all this, all right, from a very low value of k up to a very good high value of k, we are going to try in our data set, and then we are going to calculate the sum of square distance, right, like the way we have just calculated. So we are going to take k equal to 1. After doing the clustering, we are going to figure out what is the SSD, what is the sum of square distance. Then we are going to take k equal to 2. We are going to figure out what is going to be the sum of square distance, then 3, then 4, and so on. We are going to figure out what are the sum of square distances for different values of k, and we are going to plot it in a graph like this. Now this graph, it looks like a hand. Okay, so say this is a person. I'm a very bad artist. Okay, so say this is a person and this is the hand of that person. Okay, so this graph kind of looks like this. Okay, this graph. So this is called a elbow method. Okay, this looks like hand, and in this hand this part would be the elbow. That means this part would be the elbow. Okay, if this graph looks like a hand, this would be the elbow of the hand. Now a good value of k is the values of k that would be there in my elbow. For example, here this is the point at the center of the elbow. Okay, so 4 I would believe is a good value of k, or if I take 5 or 3, those are also in my elbow. Okay, but then one of these values which fall in the elbow of my hand, these graphs look like a hand, and then graph has this elbow, right? This is called elbow. So one of these values that is there in my elbow, that is a good value of k. Okay. So that is one general technique to find a good value of k when you don't know. Now say we are trying to work with IDs data. Okay, we are not given what is the class. Now I know my data has three different groups. I know there is IDs setosa, virginica, versicolor. So I already have lots of domain knowledge in that case. So in there I already know what is the perfect value of k, that is equal to 3. Or say I am trying to look at the Facebook likes and dislike of a person, and I am trying to predict who this person is going to vote for in my election. All right, then I will see that there are five candidates who are contesting the election. So I know I can separate all these people into five different groups. Okay, so I'm trying to predict who will this person vote for. So there are five candidates. So I know my k is going to be equal to 5. So in this way, I can use the domain knowledge. But if I don't have domain knowledge, then this elbow method is a good way to find what should be the optimal value of k. All right. So yeah, these are all the things that we are going to see in k-means. So with this we have come to the end of k-means. All right. So this is one of the algorithms. Uh, Now let us go ahead and move to the next algorithm. Okay, so the next algorithm that we are going to see in clustering is known as hierarchical clustering. So let us talk a little bit about what is hierarchical clustering, and then we will work with the example that we have been looking at to see in details how to go ahead and do hierarchical clustering. So hierarchical clustering is a method of cluster analysis which builds a hierarchy of cluster. Alright, so the image on the left on your screen is a data set that we have, and diagram on the right. This kind of a diagram is known as dendrogram. Alright, DENDRO gram. Alright, so this dendrogram that you see on the right, this represents the clustering that we do. Alright, so what can we see from the dendrogram? We see there all the nodes that are there, all the data points that are there on the data set on the left. In this data set, I have A to F, six different nodes, six different data points. So these are the six. And what is the way in which clustering has happened? So here I see that these nodes meet each other. All right, in a tree-like structure, they meet each other. First, this is the meeting that happens. Then I have this meeting. Then I have this. Then I have this, and finally there is a meeting that happens at this level. All right. So one meeting happening here, one meeting happening here, one meeting happening here, another happening here. Okay, no more. So what does this, the first meeting signifies? That B and C comes together to form a cluster. So these two forms a cluster. Then over here I see that D and E comes together to form the next cluster. So I make another cluster over here. Alright. Then I see here that D and E, they made a cluster, this cluster. Alright, there was a cluster containing these 2 points. Then we create a bigger cluster that contains F as well. Alright, so F, this branch that goes to F meets this branch that goes to, I have one cluster over here that contains D and E. Alright, so this cluster and F together they form one bigger cluster. Alright, then what do I see here? Here I see that this bigger cluster that I formed with D, E and F, and this small cluster that I had that contained B and E, they meet at this point. Alright, so I have another cluster that contains all of these points, and then finally I have this cluster that meets over here. Alright, this contains all the points. Alright, so this would be the biggest cluster. So this is what we have a tree like diagram called a dendrogram that represents the clustering that we are doing. Alright. So why is it called hierarchy? Because we are doing the clustering at multiple level. So you can look at this diagram from two ends. You can go bottom up or you can go top down. Alright, if you go top down, you will see that there is a hierarchy. Okay, at the very top, there is one big cluster that contains all of the points, and then we divide this big cluster into two cluster that contains two subset of the point, and then we can further keep on dividing them until we reach cluster so small that each cluster contain only one point at the very bottom. All right, so at the very top we start with a big cluster that contain all the points, to at the bottom where we have a cluster that contain only one point. All right, so this is a hierarchy of cluster, and you can look at this in the bottom of direction as well. We just talked about the top down version. Right, in bottom up we can visualize it this way, that each cluster contain only one point at the very beginning, and then we combine two of this cluster containing one point to create a cluster that contains 2 point. Then we uh, combine this cluster small clusters to contain big cluster, and then combine this bigger cluster to create even bigger cluster. All right, ultimately we end up with one cluster that contain all of the points. All right, in this way there is a hierarchy. All right, so this kind of clustering is called hierarchical clustering. Now there are two strategies, we already talked about that. One is the bottom up, where I will do this. I will first create initially each point will be a cluster of its own. All right, then I will combine clusters. So first say I am doing this. I have created this B and C, this cluster that contains only B and only C. I combine them to contain this cluster that contains B and C. Then I create another cluster that contains D and E. Then I create another cluster that contains D, E and F. Alright. Then I create another cluster that contains this. And finally I can create a cluster that contains all of the points. Alright. So this is the agglomerative process where I go bottoms up. Now contrast this with top down. In top down I will begin with a cluster that contains all of the points. Then I will divide this cluster uh, into parts. So I will create one part that contains A and the other part that contains all the other points. Alright, then I will divide this other part that contains all the other points except A into more division. So I will take that and divide that into this and this. Alright, now let us go ahead and divide this cluster that contains that contains D, E and F into two clusters. So I will create this and this. Alright, now let us go ahead and create divide this cluster that contains D and E into two clusters. Alright, so I have D and E on their own. Now I have another cluster that contains B and C. Let us go ahead and divide that as well. So I have two clusters, each containing one containing B and the other containing C. So right now what I have in my screen are 6 different clusters, each of them containing only one data point. So I started with one big cluster and I kept on dividing until and unless I reached a point where I have clusters that contain only one data point. Alright, so this is the top down approach. The other way is the bottom up approach. So the top down approach is known as divisive approach, the bottom up approach is known as agglomerative approach. So these are two types of algorithm that exist in hierarchical clustering. the algorithm that we are going to look at in this class is agglomerative. Right? So let us go ahead and look at the algorithm. It's actually very easy. Okay. So this is a data set. We saw this data set when we were working with k-means. So in this data set we have 7 people. The hours per day that they spend on Facebook and the hours per day they spend on Instagram. Here is a scatter map uh, that plots this data set. For example, this uh, person number 3 spends 3 hours every day on Facebook and 4 hours every day on Instagram. So that is what it says over here. The person spends 3 hours on Facebook and 4 hours on Instagram. Here is person number 4. He spends 5 hours on Facebook every day and 7 hours on Instagram. All right. So person number 4, 5 hours and 7 hours on Facebook and Instagram respectively. Right, so this is the scatter map. We will work with the scatter map, but then we will first work with the table with our data set, and then we will try to understand what is happening using this scatter map. So let's go ahead and work with this. First, I am going to create one cluster. All right. So we are going to do this bottom-up approach, where right now each of the point you can imagine each of the point as a cluster of its own. Now I am going to use do this. I am going to take two of this cluster and create one cluster. All right, so what is the criteria? So like KNN, the criteria was distance. All right, here also we are going to use distance as the metric. All right, so what we are going to do is the clusters that are closest together. All right, I will combine them and create a bigger cluster. So I need to find the clusters that are closest together. So right now I have 7 different clusters. Each of them contain only one point. It does not matter actually each of them contain how many points, but right now we know each of them contain one point. All right. So what I need to do is I need to find the distance of each cluster from each other every other cluster. Alright, for example, I need to find the distance between 1 and 2, 1 and 3, 1 and 4, and so on up to 1 and 7. Then I need to find the distance between say 2 and 3, 2 and 4, 2 and 5, up to 2 and 7. And then I will find from 3 to 4, 3 to 5, 3 to 6, 3 to 7, and so on. Every possible combination I need to find the distance. Alright, so how many calculations do I need to do? I need to do, if there are n number of points in my data set, then I believe I will need to do n into n minus 1 by 2 number of calculations. So I have 7 points. It would be 7 into 6 by 2, that would be 7 into 3, so 21. Alright, so I need to find 21 different distances. Okay, and that is what I have found. So the distance between 1 and 2 is 1.12. Distance between this says distance between 2 and 7 is 3.2. Here it says distance between 6 and 7 is 1.11. In this way I have found every possible distance between every possible pair of points. Alright, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7, then 2 3, 2 4, 2 5. Alright, and so on, 3 6, 3 7, 4 5, 4 6, 4 7, 5 6, 5 7, 6 7. Now one thing that you may have guessed by now, that if I find the distance between any x y, uh, between any cluster x and any cluster y, all right, then the distance between y and x is going to be same. So that is the thing about Euclidean distance. If I find a distance between 2 points a and b, the distance between b and a is also going to be same as the distance between a and b. So if I find the distance between 1 and 6, I do not need to find the distance between 6 and 1. It is going to be same. All right, so that is one advantage. Otherwise I would have had n minus 1 square number of calculations to do, but because I don't need to do that, so I have n into n minus 1 number of calculations, so a little bit of advantage. Alright, so what do I have here? Here I have the distance calculated between every possible pairs of clusters. Right now I am saying cluster. I can say points between every possible pair of points, but let us keep saying cluster. Alright, so these are clusters right now. Each of the cluster contain only one point. Alright, so I have found the distance between every possible pair of cluster. Now what am I going to do? I am going to take the two closest clusters, combine them and form one cluster. Alright, so what are the closest? It seems 5 and 7 are the closest. So 5 and 7, those are the closest pair. I am going to combine them and make them into one. So let us go ahead and do that. These 5 and 7 are combined together. So I have created the first cluster. Now what is the thing that I have to do with the data set? This 5 and 7, alright, there were two different clusters previously, two different points. Each point was its own cluster, so there were two different clusters containing only 1 and 1 point each, 5 and 7 respectively. So these two I have joined and combined into one cluster. So I have removed the row for 5, I have removed the row for 7, and instead I have added one new row. Okay, so this new row uh, contains hold on, this fellow and this we got by averaging out. So what we are going to do, we have done this 5 and 7, they are the closest, right? They were the closest, we just figured out. So we are going to combine 5 and 7 and make them one cluster. Now how do I do this combination? I am going to take the average. So I am going to use a process called average linkage. Alright. So average linkage is essentially average that we did with k-means, where we took the average of the centroid of all the points and things like that. So we are going to do the same thing. Alright. So 5 and 7 is going to give us a new cluster. Okay. So our new cluster will contain 5 and 7, and this will be represented by this point. Average of 3.5 and 3.5 is 3.5. Average of 5 and 4.5 is 4.75. So this is the point that would be representative of this cluster. Okay, this cluster containing 5 and 7. So let us do that, and we have done that. Okay, so we have added this row to our data set that is representative of this cluster that we have created right now. Alright, we have created our first cluster. This cluster contains 5 and 7, and this is the row that we have added to our data set that indicates that we have created a cluster. And then this cluster needs a point representing the cluster. So we have taken the average. Alright, and I just told you how to take the average. Just take the average of each column in of the feature, and yeah, that is the way to do that. Alright, so this is how we did created our first cluster. Alright, now let us go ahead and try to create our second cluster. To create our second cluster, what we have to do is we have to once again find all of these are clusters, right? These 6 are cluster, each of them contain 1 point. This is another cluster. Now this contains 2 points, right? So I have right now 6 different clusters on my data set, and I have to find every possible pair, so distance, right? So I have to find the distance from 1 and 2, I have to find the distance from say 2 and 4, and every possible pair I have to find the distance between 1 and 5 7. Alright, so let us go ahead and do that. This is the distance between 1 and 2, this is the distance between 1 and 3, this is the distance between 1 and 5 7. So the distance between this point and this point that represents this cluster. Alright, so once again Euclidean distance, simple formula. This is the distance between this. Alright, so in this way we have found all these clusters, distance between every pair of clusters. Alright, and then what am I going to do now? I am going to take the two clusters, okay, and combine them to create a bigger cluster. Alright, so which two am I going to choose? Which two cluster out of all these clusters? So there are 6 clusters present in my data set right now. I am going to combine two of them. Which two am I going to combine? The two that are closest to each other. So we have found the distance between every possible pair. This, it seems, is the closest. Alright, so 3 and this. So I'm going to go ahead and combine them. Alright, now I'm going to go ahead and combine them. There is a bit of confusion. Okay, how do I uh, get the average? Okay, uh, previously I combined 5 and 7. I took the value of 5, I took the value in the column that was there in 7, and I added them and I divided by 2. So it would seem as if to do this average linkage, I would take 357 for this cluster. I would do 3 plus 3.5 by 2 and 4 plus 4.75 by 2. Alright. So it would seem I would want to do this, but this is incorrect. Alright. This is incorrect because I am giving this and this equal weightage. Alright, if I just divide, but then this has 2 points and this has only 1 point, right? So these two rows should not get equal weightage. So what I'm going to do is to calculate this, okay, to calculate the average of this cluster that contains 3, 5 and 7, this new cluster that I'm going to create. Okay, why am I creating this new cluster? Because among all the clusters that were present, 3 and 5, 7, okay, this cluster that contained only 3 and the cluster that contained this pair 5 and 7, those two are the closest. So I have decided to combine them and create a new cluster. Alright, so 3, 5, 7 is going to give me a new cluster. Fine. Now I need a point that represents this cluster. I need to take the average. So I will take the average of 3, 5 and 7. So hours on Facebook, the average value will be 3 plus 3.5 plus 3 divided by 3, and that is going to give me 3.17. Hours spent on Instagram, that is going to be 4, 5 and 4.5. 4 plus 5 plus 4.5 divided by 3, and that is going to give me 4.5. Alright, so I have written 4.5. So this is how I do the average linkage. Okay, this is how I find the average. Alright, so don't confuse that. Don't simply take this and divide by 2 to find the average. So I combined this cluster that had 5, 7. The center the average value, the centroid of that cluster was this 3.5 and 4.75. Alright, then I will combine that with this point 3 and 4 to create a bigger cluster. Now do not add these 2 and divide by 2. Okay, don't do that. If you do that, then what is the problem? The problem is that we are giving equal weightage to this row and this row, but this row should be given more weightage because this row contains more points. Alright, so what is the better thing to do? Simply take the average of all the points in the cluster. So I am taking the average of this 3 to get this value. I am taking the average of this 3 to get this value. Alright, so that is how I get the new average of the centroid that represents this cluster. This cluster contains now 3, 5, 7. So what is the thing that we have done till now? previously we had this cluster that contain 3 and 7. Now we have created this bigger cluster that contains, sorry, previously I had this cluster that contained 5 and 7. Now I have the bigger cluster that contains 3, 5 and 7. Alright, so we are growing the size of our cluster. Okay, so I remove that row that contains 3, and this is the new row in my data set. Now how many clusters do I have? I have this and this 4 cluster that contains only 1 point each, and then I have this big cluster that contains 3 different points. All right, so I have 5 different points in my data set. Now what is the next thing that I'm going to do? The same thing that I did. Okay, I'm going to take the two closest cluster and combine them to create a bigger cluster. So how do I find the two closest cluster? I find the distance between every possible pair of clusters. Once again, I have to find between 1 and 2, 1 and 4, 1 and 6, 1 and this cluster containing 3 different points, then 2 and 4, 2, 6, 2 and this cluster containing 3 different points. Alright, so in this way I find for each possible pair. Alright, so that is what I have done. Found between every possible pair. Now what is the next thing that I should do? I should combine the two clusters that are closest together. So what are the two clusters that are closest together? I can see among all these different possible pairs of clusters. So this is the distance between 1 and 2. This is the distance between 1 and this cluster that contains 3, 5 and 7. Alright. This is the distance between 2 and this cluster that contains 3, 5 and 7. So the minimum distance between all possible clusters is this 1.12. Alright. So I'm going to take 1 and 2, combine them to create a new cluster. And then what am I going to do? I'm going to remove these two rows. Alright, and then I am going to put a new row that represents the cluster containing 1 and 2, and then what will be the value here and what will be the value here? The value here will be the average of these two. Okay, so that is going to be 1.25, and the value here is going to be the average of these two, that is going to be 1.5. So let us go ahead and do that. Okay, we have created this row, and then we have just now created this cluster. Alright, we had already created this before, and now we are creating this cluster. Okay, so yeah, let us now go ahead, and now how many clusters do I have? 1, 2, 3 and 4. This cluster contain 2 points, this and this cluster contain 1 point each, this cluster contain 3 points. Alright, this contain 2, this contains 1 each, and this contain 3. So how many clusters do I have right now? In total on my data set I have 4 clusters, and I have to find the distance between every possible pair. So we have found the distance between every possible pair. Here is the distance between 1, 2 and 4. Alright, this is 6.66, the number of the beast. Alright, this is the distance between 1, 2 and 6. Okay, I just said number of the beast. That was a joke, so that you don't need to understand that for machine learning. Okay, forget that. Uh, Here is the distance between 4 and 6. Alright, we have all this. So among all these distances, which is the minimum? This looks like the minimum. The distance between 6 and the cluster containing 357. Alright, so we will combine these two, and then we will create uh, new point. Alright, a new cluster, bigger cluster that contains 6, 3, 5 and 7. So we had one cluster containing 3, 5, 7. We had another cluster containing just this 1.6. We will combine these two cluster, and then we will have a new cluster that contains this 4 point. Alright. Now question, how do I figure out the centroid? How do I get the centroid of this bigger cluster that contains 6, 3, 5 and 7? I will add them up, right? Whatever value was there, I have to do 6, 3, 5 and 7. So I will go to this original data set. Okay, I will take 6, 3, 5 and 7. I will take the average of these four numbers. Whatever be the average will be the hours on Facebook value of this new cluster. And in the same way, I will take this and this, sum them up and divide by 4. I will take the average, and that would be hours on Instagram, this value. Right. So that is how I will find. Once I have combined these two, I will get those average values. Alright, so this is the average that I found. Okay, and this is the new cluster that I have created. So I had this cluster before. There was this another cluster containing just the 0.6. So just the 0.6, and then we create this cluster, this new cluster that contains these four different points. So this previous cluster containing three different points and 6. Alright. Now I have three different clusters remaining on my data set. Let us go ahead and find the distance between each of them. So I have a distance between 1, 2 and 4, the cluster containing 1, 2 and 4. Distance between the cluster containing 1, 2 and the cluster containing 6, 3, 5, 7, and the distance between this point 4 and the cluster containing 6, 3, 5, 7. Alright, so among all this is the minimum. So what am I going to do? I am going to combine these two clusters, this cluster containing only 4 and the cluster containing this point 6, 3, 5 and 7. I am going to take these two clusters, combine them to create one cluster. So let us go ahead and do that. And once again, I expect you to know by now how to find this and this value. I will take see the hours on Facebook, this value. How did I get this? I took the value on row number 4, row number 6, row number 3, row number 5 and row number 7 of the data set, and I averaged them. All right, in the same way I got this value. I took the value from row number 4, 6, 3, 5, 7 and I averaged them. All right, so column wise average of all the points that are there in the cluster. So right, so I have 4, 6, 3, 5, 7 in the cluster. So I will take the values of 4, 3, 6, 5, 7 from the original data set. I will average them, and that is how I get this value and this value. Right, so this should not be a very difficult idea to grasp. Right, so that is how what have I done right now. I had this old cluster containing 6, 3, 5 and 7, and I had this point 4. I combined these two to get this bigger cluster containing all these points. Alright, 4, 6, 3, 5, 7, 7. Alright, next what am I going to do? So I have only 2 points. There is no point in finding the distance between these two. I have two clusters remaining, one that contains 1 and 2 and the other that contains all these different points. Alright, so two different clusters on my data set. I don't need to find any distance, I have to combine these two. Alright, so let us go ahead and combine these two. Alright, and then I find the average of all the points that are there in my data set, and that is representative of this big cluster that contains all these points. Fine. So this is how hierarchical clustering works. Lots of calculation, but very simple idea. All right. Now the thing is, don't be worried about calculation. All right. If you understand the idea, you are of course going to write a program that is going to carry out the calculation for you. Okay. Now in your exam, you may have to work a little bit with pen and paper or your calculator, and you may have to do a little bit of calculation. But in real life, if you go to industry, if you are participating in any competition, or you are going to academia and research, in that case, uh, you really don't need to do any calculation, right? You will write programs that do the calculation for you. But in order to write programs, you will need to understand what is going on. All right, and understanding hierarchical clustering is very easy. This is a very simple algorithm. All right, although lots of calculation are involved, but simple calculation nevertheless. So this is how we have done clustering. We have done our clustering. Let us go ahead and create the dendrogram. This is the dendrogram representative of this clustering that we have done. All right. So what is the first thing that we do? First thing we combine 5 and 7. After that we combine 3, 5 and 7. Alright. After that we combined 1 and 2. After that we combined 6, 3, 5 and 7. Okay. After that this. Okay. Right now I have this one cluster and this is another cluster. Alright. And finally we combine these two to create one big cluster. Okay. So one thing you might have noticed, there is some time series information. Okay, the in this dendrogram, the one that is combined first is shown at the top, the one that is combined next is below that, the one that is combined next is below that, the one that is combined at the very last is at the lowest level of the diagram. Okay, so by looking at the diagram, we can also know when this combination took place, which was combined before, which was combined later. Okay, so this combination of clusters, right? So yeah, this is what we have. Okay, so I don't think there should be much confusion regarding what we are doing. Okay, this is a very simple algorithm, but if you still have doubt, reach out. Okay. Now, there is one more thing that we have to talk about. To find distances, okay. Now, say this is a point and there is another point. Okay. Finding distance between these 2 points is very easy. Okay. Just apply Euclidean formula and we are done. But there is a bit of philosophies to think about, things to think about when we are trying to find distance between say two clusters. So I have this cluster and this cluster, all right, and I have this point. How do I find the distance between this point and this cluster? Right. Up to this point, what we have been doing is we are taking the average of all these points. So this is a cluster that contains this point, and this point. We have been doing average linkage. In average linkage, what are we doing? We are taking a point that is average of all the points that are there in my cluster. So this cluster contains 3 points. This point would be the average of all these 3 points, right? Average of each uh, feature in my data set, so that would be representative of the cluster. That is what we have been doing up to this point. We have been doing this in k-means as well, we have done this in hierarchical clustering as well. Okay, but this is not the only solution. Okay, so to find the distance between this point and this cluster, we took the average of this cluster and we found the distance between the average and this point. So that is what we have been doing up till now, right? This is average linkage. Now in single linkage, okay, there are two other techniques. One is single linkage and one is complete linkage. I will take, say, I want to decide where will this point go. It will join this cluster or will it join this cluster? Here is how I will decide. Uh, I will find the distance between this point and this cluster's nearest point. Okay, this point would be nearest to my point, and therefore I will find the distance between these two. Okay, this point which is nearest to my point. Okay, and in the same way, say this is the point that is nearest to my point, so I will find this distance. Okay, so in single linkage, from my point, I will find the distance to the cluster's nearest point. Okay, now out of these two distances, I have found this distance, that is the distance between the nearest point of this cluster and my point, and I have found this distance, which is the distance between the nearest point of this cluster and my point. Alright, so I have found these two distances. Out of these two distances, whichever is small, so I can see visually that this is small. Okay, so what I will do is I will make this as the next cluster. Alright, so I will not take this point, I will not put in this cluster, I will make a new cluster with uh, this. Alright, so what will I do? I have this point and I have different clusters from where I have to find the distance. The distance that I take from each cluster will be the distance from my point up to the nearest point in that cluster. Alright. In average linkage, I was finding the distance from my point up to the average of that cluster. In single linkage, I will take my point and find the distance to the nearest point of that cluster. In complete linkage, I will do the opposite. Okay, I will find the distance from the furthest point. Say this is the furthest point and this is the furthest point of these two different clusters. All right. So I will find the distance this and I will find the distance this. Alright, in complete linkage, I will try to find the distance from the farthest point. Okay, and among these two distances that I have found, which cluster will I choose to combine this point with? Will I combine this point with this cluster or should I combine this point with this cluster? The one that is smaller. Say this distance is smaller. Okay, so I will create this as the cluster. Okay, so what is single linkage? Single linkage, from my point I am finding the distance to the nearest point in the different cluster. In average linkage, I am finding the distance from my point to the average of each of the cluster. In complete linkage, I am finding the distance from my point to the farthest point in each of the cluster. And then my point, which one should I, which cluster should I combine my point with? The one that is giving me the minimum distance. Okay, be the distance through average linkage, be through single linkage, or be through complete linkage. Okay, whatever be the mode with which I am calculating the distance, my choice, which cluster do I combine with? I will combine with the cluster that is giving me the minimum distance. So that is what we did with average linkage. I found this distance and this distance, the distance from my point to the farthest, this is with complete linkage, to the farthest point in the two different cluster. Which one do I combine my point with? Do I combine with this cluster or this cluster? Whichever distance, I found this distance and this distance, right? The two distances from the two different farthest point in these two different clusters. Alright, which one do I combine with? I combine with the one that is minimum. So if this, say this is x, this is y, if x is less than y, then I will combine my this point, my point, with this cluster, and this is the next clustering that I am going to do, the bigger cluster that I am going to form in my hierarchical clustering. Alright, so this is what it is. Alright, so this is the difference between complete, single and average linkage. Average linkage, I find the distance from the average of the cluster to my point. In single linkage, I will find the distance between the nearest point to my point. In each cluster, I will find the distance from here to here. In complete linkage, I will find the distance between the farthest point and my point. Right? So yeah, these are different ways to find the distances to determine which clusters should I combine with. Okay, now advantage of hierarchical clustering is this: if there are n data points, okay, then I can recursively partition. I will have say this is one cluster. If I need one cluster that contains all of this point, that is pretty much useless. All right, if I have only one cluster, there is no need to apply any algorithm at all, right? Every point will belong to this one cluster. But say I need 3 clusters or 4 clusters, then this algorithm can recursively give me 3 clusters or 4 clusters. Okay, so I am going to show this with example. Say this is the clustering that has happened. This is the dendrogram representing this clustering. If I have these 5 data points, all right, 1 to 5. If I need 2 clustering, all right, I need to divide my data into 2 groups. Then I will get this one group containing 1 to 3. This is one clustering. Okay, and I will get this other group containing 4 5. This is another clustering. So I get 2 different clusters. All right. On the other hand, if I need 3 different clusters, then what am I going to do? I get this one cluster, this is another cluster, and this is another cluster. Alright, so one containing 1 2, one containing 3, and one containing 4 5. So if I need 3 different cluster, I will get this 3. If I need 2 different cluster, I can get 2. If I say I have n different points in my data set, I can go from 1. If I need 1 cluster, I can go 1. If I need 2, I can divide into 2, 3. I can go up to n clusters. Right? So the number of clusters that I need, I can get as many as I want using this single algorithm. Alright. Now how many clusters do I need is actually going to depend on your application. So say you are selling in big bazaar, and then you want to divide your customers into food and non-food. Okay, so you will need 2 clusters. Now you say want to divide into food, cosmetics, and clothes. You will need 3 clusters. Okay, so depends really on your application, on what you want to do. Okay, so this is where domain expert will come in and tell you how many clusters to divide into. Then they will see, do analysis on the data that these clusters contain, and then figure out what the cluster mean. So lots of things that have to be done once clustering is done. Okay, or say today you want to give simply in Zomato you want to give one coupon code to vegetarian people, one coupon code to non-veg people. So you will need 2 cluster, all right, to divide all your customers into 2 different cluster. If you want to say give 4 coupon code, one coupon code for dosa people, one coupon code for momo people, one coupon code for Chinese, one coupon code for Indian, North Indian food. Okay, so you will need to divide into 4 different cluster. All right. So yeah, really depends on the application. And then what hierarchical clustering does is, whether you want 2 different cluster or 4 different cluster, any amount of clusters that you need, this single algorithm can give you, right? So you just need to, at the very top you will have all your customers in one cluster. Then you come a little bit down, you will divide into 2 groups. All right, then you come a little bit down, you will divide into 3 groups, and then 4. So here I have all the customers. Say if I split here, uh, I will have this as one split and this as the other. I have this 3 customer on one side, this 2 customer on one side, and if I come and split here, I will find these 2 customer on one side, this customer being alone, and this 3 customer on one side. If I come and split here, I will see this. If I come and split here, okay, I will see that this is one customer alone, this is one customer alone, this is alone, and these two are together. All right, so in this way I can keep on going. If I split here, I will see that each of them is alone. Okay, I have 5 different split, so I can get 1 split, 2 split, 3 split, up to, if I have n different data points, I can get n different split. So this is one big advantage of hierarchical clustering. All right, so the next algorithm and the final algorithm, we are not going to go deep into this algorithm. We are just going to have a very high level overview. is the DBSCAN clustering algorithm. This is the most powerful. Okay, so I should have spent most of my time in this algorithm, but uh, I'm going to give you a very high level overview, and I hope that would be enough information for you to go ahead and implement this algorithm. All right. Uh, I'm going to give you sufficient information. I am simply not going to take an example and work with it like we did with the last two examples. Okay, what is DBSCAN? The full form is density based spatial clustering of application with noise. Very powerful algorithm. It has this concept of noise or outliers that no other algorithm have. It is based on density. Okay, you will understand very soon. So given a set of data points, it groups together points that are closely packed together. Okay, and then things that are far away. So all these points that are closely packed together will be a cluster, and points that are not close to any other points will be marked as outlier, as noise. All right. Uh, so those are points. Outliers are points that lie alone in low density region. So let us go ahead and look more into it. Okay, before we go ahead and look more into it, we will need two parameters. One is epsilon and the other is mean points. Okay, so there are a few things that we are going to do. See, we have drawn circle over here. All of these circle are of equal size. Okay, so what is the radius of the circle? That is given by this epsilon. Okay, you will understand what the circle mean. And there is something called mean points. Okay, now what is mean point? We have over here set this epsilon, the radius of the circle, to some value. Okay, and mean points we have set to 4. Okay, now what does this mean? Okay, now around each point we have drawn the circle with radius epsilon. Okay, around each point, this is the circle around this point, this is the circle around this point, this in yellow, very low contrast, is the circle around this point. In this way we have drawn circle around each point. Now let us take this circle, this point's circle. This is the circle representing this point A. Okay, how many points are inside this circle? I have this A, I have this one, I have this one, and I have this one. So I have 4 different points inside this circle. Okay, so my minimum points that I had set at the very beginning was 4. Okay, so how many points are there inside this circle? There are 4. So minimum number of points that was required, this condition is satisfied. This is not a problem. This is good. What is the good thing about this? It means that this point that contains more than the minimum number of points in its circle, okay, this point is called a core point. What is a core point? A point P is a core point if at least minimum number of points are within distance epsilon of it, including P. So including A, in our case we are talking about this A point, including A, I have these 4 points inside this circle that is that has this radius epsilon, okay, around it. So A is the center of the circle, and then I draw a circle with radius epsilon, and then I see that there are 4 points more than or equal to this minimum points that I had set minimum points equal to 4. Okay, so this condition is satisfied, therefore this point is a core point. Now if you pause this video and observe, you will see that each of these red points is a core point. Each of the point drawn in red is a core point. Let me take this as an example. This is a point and this is the circle representative of this point. Okay, so inside this circle I have this point, this point, this point, and this point. So I have at least minimum number of points. What is minimum points? Minimum points is 4. How many points do I have inside my circle, including the point that is at the center of the circle? I have 4 points. So I have at least 4. Okay, 4 is at least 4. So I have greater than or equal to mean points. Mean point was 4. Therefore this point is also a core point. Okay, if you observe, you will see all these red points are core points. Okay, a point Q is directly reachable from P if Q is within epsilon distance of core point P. So this is directly reachable from A. Okay, so inside this circle I have this point, this point, and this point. This circle is of radius epsilon. Alright. So inside this circle I have all these different points apart from A. So all these points we will call them directly reachable from A. So from any point P, if there is a point which is at a distance of less than epsilon, then that point is directly reachable from P. Okay, so uh, what is this epsilon? This epsilon is the radius of this circle that we are drawing around this point, right? Our point is A. We have drawn a circle around A. The circle has a radius of epsilon. Inside this circle there are a few points. So all these points are those are inside this circle are at a distance of less than epsilon, right? So if that distance was more than epsilon, it would not be inside the circle. If uh, from the center of a circle, all right, if there is a point at a distance greater than the radius of the circle, then the point will not be inside my circle, right? So all these points that are inside this circle around A has a distance from A less than epsilon. So all these points that are inside my circle are directly reachable from that point which is at the center of my circle. So A over here is at the center of my circle. This point, this point, and this point, all of these are inside this circle that is around A at a distance of uh, epsilon with a radius of epsilon. All these are directly reachable. Okay, now this was directly reachable. Another is reachable. Okay, now see this point. Okay, there is a path from A, this point is reachable. From this point is reachable. And from this point, B is reachable. Okay, so there is a path from A to B. Okay, from A to B such that there is a path like this P1, P2 up to Pn, where P1 is A and Pn is B. Okay, and every Pi plus 1 is directly reachable from Pi. So from this point is directly reachable. Okay, then from this point is directly reachable, and from this point B is directly reachable. So from A, there will be a point which is directly reachable from A, and from that point, there will be a point which will be directly reachable from that point, and from that, there will be another point which will be directly reachable from this previous point. And finally, after doing this, going from one directly reachable point to another directly reachable point, right? So after doing this for many steps, I will finally reach B. So A and B are not directly reachable, but there is a path through which I can reach B from A. Okay. Now each of these path, two adjacent points on this path have to be directly reachable. Okay. So this and this are on the path. These two are directly reachable. This and this are on the path. These two are directly reachable. These two. Okay, these two are directly reachable. Then these two are directly reachable. So we have this. Right? A point Q is reachable from P if there is a path P1 to Pn with P1 being P and Qn being Q. Pn being Q. So P1 in our case is A, Pn in our case is B. where every pi plus 1 is directly reachable from pi. So every two adjacent points on this path have to be directly reachable. Every two adjacent points on this path have to be at a distance of less than or equal to epsilon from each other. Alright, so that is one more requirement. Now this B is therefore reachable from A. Okay, there is a path. Now A and B are not directly reachable, but then uh, in between all these points, A has one point next to it that is directly reachable. Then that point has a directly reachable point. That point has a directly reachable point. And finally, I have one point from which B is directly reachable. All right. So A to B is reachable. B is reachable from A. Fine. So in the same way, C is reachable from A. This point is directly reachable from A, and C is directly reachable from this point. Alright, so C is reachable from A. Right, so we have seen directly reachable, we have seen reachable. Finally, there are some points which are neither not reachable from any other point. Now there is one more thing. Okay, in this path from A to B, uh, there is one more strictness that all the points that comes between A and B, all of them have to be core points. So there is this other definition. Let us not worry about that. We will not have this restriction. Okay, that is going to be true anyway. That is kind of implied, but let us not think about that. Let us look at this point N. Okay, this point is not directly reachable. So A, there is no point over here. Okay, had there been a point over here, then these two would be at a distance of less than epsilon, and from here I could go to N. Okay, this point would be directly reachable from A, and from here I could go to N. This point would be directly reachable from N and directly reachable from A. So I will have this point acting as the bridge between N and A, and N would be reachable from A. But we don't have any such point. Okay, so there is no path between N and A, all right, or N and any other points in this cluster uh, over here, any of the points over here. All right, so N we are going to call it noise or outlier. All right, so these are the different concepts we have. We have core points. We have points that are directly reachable from the core point. Okay, those are points within this core points circle, all right, at a distance of less than epsilon. Then we have reachable points which are not inside core point circle, but then we can reach from this core point up to that point through some path. All right, and each intermediate point in this path is directly reachable from the previous point in the path. Okay, and then we have noise. Now if P is a core point, then it forms a cluster together with all points that are reachable from it. Okay, now A is a core point in our case. Okay, we have considered A to be a core point, and we have seen that all these points that are in red are core points. So all these points that are directly reachable from A, okay, we will form one cluster. So this point, this point, this point, this point, they are directly reachable. What are the other points that are reachable? I can go from A to here. Okay, let me change the color. Is green going to be a good color? Yeah, there is no green. From here I can go up to here. Okay, and then I can go up to here. So although this point is not directly reachable from A, but it is reachable. Okay, this is directly reachable from A, and this point is directly reachable from this point. Okay, therefore this point is reachable from A. This is directly reachable. This is directly reachable. This is reachable. We just talked about that. This is directly reachable. This is reachable from this point. This is directly reachable, and from this point, this is directly reachable. So therefore, this point is reachable from A. Okay, and then this point is reachable from A. This is directly reachable from this. This is directly reachable, and from this is directly reachable. Therefore, this B point is reachable from A. Alright, so all these points are directly or indirectly reachable from A. Therefore, all these points will be in one cluster. Okay. So if P is a core point, then it forms a cluster together with all points, core or non-core, that are reachable from it. Alright, not only directly, but even if indirectly reachable, but yeah, if it is reachable, then together all these points will form one cluster. Now each cluster contain at least one core point. Okay, yeah, this is because of the last point, that if P is a core point, then only it can go ahead and decide to form a cluster. Non-core point can be part of a cluster, but they form edge. Okay, so this non-core point, B is a non-core point. We cannot use B to form more points to go ahead. Okay, this will be the edge of the cluster. We cannot use B. See, in B's circle, I do not have 4. I have only 2 points inside this B's circle. Okay, so this is a non-core point. Okay, I have less than minimum required number of points. So I cannot use B to grow my cluster anymore. Okay, I cannot have a path going through B uh, according to this definition. So they cannot be used to reach more point. Alright. Now the algorithm is very simple actually. Find the points for each point and that are at a distance of epsilon. Okay, so go ahead and for each point find how many points are inside my circle. Okay, how many points are there in the data set including myself that are at a distance of less than epsilon. Okay, so find that, and then if this point has if any particular point has distance greater than alpha, has number of points in its neighborhood of epsilon greater than minimum point, then that is going to become a core point. Okay, now once you have discovered all this core point, find all these connected component of core point. Okay, so find the connected component of core point. All these core points will first form a cluster. Then uh, from this cluster, the node core points that are reachable from this cluster of core points, join them to this cluster. Assign each non-core point to a nearby cluster if the cluster is epsilon neighbor is at a distance of epsilon. Okay, so you will have a cluster formed with core point, and then this known core point, if they are near these core points, they are at a distance of less than epsilon from a core point, then that would also be a part of the cluster. Okay, if these points are not at a distance of less than epsilon, then this is going to be a noise. Otherwise, assign it to noise. Okay, so this is the basic idea behind DBSCAN algorithm. We are not going to do any actual calculation using DBSCAN in this video. Okay, but I am going to show you a animation of how DBSCAN actually works. So let us go ahead and look into that. So from the beginning, I have these points where a cluster is being formed. Okay, so we are looking at the neighborhood and then we are trying to grow. Okay, so this is the first cluster that we form. Then we are forming the next cluster. Okay. Then we are forming the third cluster, and finally the fourth cluster, and the remaining points that are not densely connected to anything else, that becomes noise. Alright, so this is the DBSCAN algorithm. This is essentially how it works. Now let me show you why DBSCAN would be preferred. Okay, some advantages. Uh, DBSCAN does not need any predetermined number of clusters to be told. Like in k-means, I had to determine what would be the value of k, how many clusters we are going to have. Okay, so that is not required in DBSCAN. DBSCAN can find arbitrary shaped cluster. Okay, this is one of the biggest advantage of DBSCAN. Let us look at this. Okay, these are examples where DBSCAN shines. Okay, here you see this inside circle has one, it belongs to one cluster. This outside circle is determined as another cluster. Contrast that with k-means. K-means is performing really bad. K-means is doing what? It is doing linear, it is creating linear boundaries. Okay, so here I am creating a linear boundary like this, but DBSCAN is shining, it is creating this into one cluster, this into another cluster. Right, here k means I can see this is one cluster, that is fine, this is another cluster. K means, they told k means that you have to find three cluster. K mean is going ahead and finding three cluster. Here k means divides into three cluster, this is good. DBSCAN is performing equally good. Here k-means is asked to find three cluster, it is finding three different cluster. But DBSCAN sees that there is no clustering, there is only one cluster, everything is jumbled together. So there is only one cluster, and DBSCAN finds one cluster. Okay, but in fact, if you look at these two examples, you can really see why DBSCAN might be preferred. DBSCAN can do non-linear clustering. Okay, here it is in k-means it is very linear. We are simply drawing lines as boundaries to divide our entire area. We are drawing lines, and that is how we are dividing our entire area. Actually, we are creating Fornoid diagram, but don't worry about that. We are simply drawing lines. Think of it as line. Okay, but DBSCAN we are drawing curves. Okay, so that is good. DBSCAN can find arbitrary shaped clusters. DBSCAN has the notion of noise. Okay, so in k-means we will try to put every point into one cluster or the other. If there is some faulty error data, if there is some outlier or there is some noise, we will still try to accommodate that into our clustering. DBSCAN is resistant to noise. If there is some noise, DBSCAN will identify that this is noise, this is faulty, erroneous data, that is an outlier, and it will not take that into consideration. Right. So this is another advantage of DBSCAN. Now, DBSCAN just requires two parameters, that is our epsilon and mean points, and it is mostly insensitive to the ordering of the point in the database, so it does not matter how the points are there in my database. Really, now these two parameter mean points and epsilon can be set by domain expert if the data is understood properly. Okay, so application dependent, domain expert can come in and tell us what is the minimum points that are required and what should be the value of epsilon. Okay, so just two parameters that we have to set. Now you can say k-means is better because we just have to set one parameter k, but then yeah, whatever. It performs better. DBSCAN performs better. All right. So this ends our video on clustering. All right. Now I hope this video has given you enough intuition behind what are the kind of things we do in clustering. We have seen two algorithms, k-means and this hierarchical clustering, in depth. Okay, we have done uh, solving using this algorithm. Okay, I hope you have understood them properly, And DBSCAN clustering, although we did not go and solve any problem using this algorithm, but I hope you have a general idea of what are the things that needs to be done. Okay, we just find neighbors first, then we form a cluster with core points, and then we add all these points that are not core points but are reachable from these core points. All right. So that is how clustering is done. That is how we form one cluster, and there will be some points that are not reachable from any uh, cluster of core points. Okay, so those will be called noise, uh, and that is how clusters are formed. I hope you get this idea why DBSCAN can do this kind of things. Why DBSCAN can do this, and why K-means is doing this. Okay, once you understand that, okay, you have to really think. You have take some time think about why this is happening. Think about how the algorithm will work on this kind of data set. Once you understand that, uh, you would have understood a large portion of these algorithms. Right. So this would be all for today's video. I really hope you understood everything. Okay, we will not be talking about clustering anymore in this course. If you have any doubt regarding today's video, feel free to reach out to me on WhatsApp, on mail, or write your doubts in the comment section below. Thank you for watching this video and see you in the next video.